within the next 1.5 hours, we will ask ourselves the question, how can data science help with environmental issues? And for this, I would directly like to welcome our first speaker, Christina Hirschl. So Christina is head of the division sensor systems at Austria Labs, which is an industry-oriented research and development center. Formerly, she was the area manager of smart systems at Community and Tech Research. She studied physics at the University of Vienna, and today Christina will give us an overview on how data science can be used for the optimization of sensor networks, which is essential, for instance, for environmental monitoring. And with this, the stage is yours. Thank you.
Thank you very much, Nathalie. A warm welcome also from my side, and I'm very happy to be here. I'm proud to be part of such a great event here. So, let me tell you a little bit about the combination of hardware and data science. Austria Labs here in Villach, we focus more on the hardware side, and I would like to tell you first a little bit who we are. We are a non-university research organization, as Nathalie already mentioned, owned by the Republic of Austria. But you see the second shareholder there is the Electronic Fachverband. This means we are really industry-driven. So a huge portion of our money we spend comes from industry. And this brings me also to the storyline of Austria Labs. We are focusing on electronic-based systems. So we have this, or we emphasize for the bridge function between universities, universities of applied science, towards industry.
May I interrupt? Your link is touching. Sorry for that, but it's
Yeah.
the live stream, we hear it all the time.
Yeah.
Thank you very much.
I don't hear it. And also the federal states of Carinthia, Styria, and Upper Austria are included. In the moment, we are about 260 people working in Villach, Graz, and Linz together, and we are planning to become around about 340, 360 2023. So we have really a huge growth path for the upcoming years. What are the focus topics for us? And this is already telling you a lot about our vision. We have on the one side more the hardware-oriented part, where our part are the sensors. Then we have power electronics, we have this communication parts. But then overlaying is a big part, this is embedded systems. Embedded systems really means, what are we doing with the data we gather down here? We send them, we communicate them, but then something needs to be done with the data. And I think this was in the last years a huge challenge also for industry. Everybody measured. A lot of data have been generated. And the challenge, nothing was done with the data. And measuring without analyzing, it's not worth doing it. It's not worth storing it. And something that is also very important in this context is which data we need to analyze. Because if we send every value we measure around, what would this mean? We would need a lot of energy for sending these things around. So the most important topic is here, for everything is getting smart in our life. And this is also the context to environmental system. We always have to keep in mind making our things smart. Just convenience, or is it more? And I think many of these slogans I wrote here is really there we can make a difference for the environment. Because if we think about industry, when the industry processes are optimized, we will need less energy, we will need less chemicals and all this. So it's really worth to go in this direction. The same is everybody knows about smart home, smart mobility, health topics. So I think all these things are really making a difference. When we think about Internet of Things, we always have a quite challenging combination to face. It's not only the things, the sensors, They are the senses of our technical world, but still, it's not enough. We have to connect it to the people. We have to connect it to the processes. And a huge part is also the data we need. And then I think the crucial part is this combination. It's not software, it's not hardware. We have to think about the combination and how to combine it in a most efficient way. For smart manufacturing, you all know, in each device, many sensors are inside. We gather a lot of data. We have to do something with the data. I'm not a data scientist. In my PhD, I made simulation of chaotic systems, so I have some ideas about the mathematical background, but not enough for data science. But for us, it's important to say, not AI is the way, because I really hate these groups. We are doing AI, we are doing machine learning. But real science is to think about the problem I want to solve and to find out what is the best way. If there is an analytical way to calculate it, we should do it. But if the data, we generate so many data that there is no chance to find out something from this data, we have to think about other algorithms. And I think this is for us really the most important part to make this decision. What makes sense for us to look at the data? And the topic in the industry is predictive maintenance. Everybody knows. Increased productivities, reduced downtimes, improvement for resource management, energy efficiency, and quality topics. And we think about all this. We always have the situation, the sensor is gathering the data, we combine it somehow, but then we need to make a decision. What is the right path to follow? And I think this is something that a data scientist should always be aware of. Not one of the model is the only solution. We have to find it out what is the best way. For the Internet of Things, I want to tell you a little bit about what is our world. For us, for the industry, it's most time it's a combination what the industry wants to solve. We have on one side these fine monitoring systems. On the other side, we have the optimization topic. And these are the challenges the industry have in the moment. If you look at this as figure 2, you see how it changed in the last years. That really this cloud part gets bigger and bigger. And if we look at this picture, we see how much data are gathered. And the industry, when we talk about industry application, we have a huge topic there, because a semiconductor fab, they do not want the data in the cloud. They do not want the data get out of the fab. So it's the next important thing about this topic is where to evaluate the data. And we all know, if we think about machine learning and all this learning, neural network learning topics, we always have the topic where to do it. Should we do it immediately on the sensor? Should we do it in the cloud? Where is the best position? This is something that for all of our projects is a huge topic in the moment. And all these topics, when we install sensors, we face the environmental issues for all of our projects, because, believe me, if I talk about microelectronic, this is nothing what is environmentally on the plus side, because the new clean room has 3 megawatt power supply. Then I have a storage of the chemicals. I think there are chemicals in-house for the new clean room of 300K just for the daily business for 2 months. And so, no, nothing. And if we think of microelectronics, it's mass production. So it's not about building 2, 3 sensors. It's a huge number of sensors. So this has nothing to do with environmental plus or on positive side. But we have to really use the devices we manufacture, and then with this data we gather, we have to improve our world. And I think this is a crucial part there. One of the topic here, in many cases, I already mentioned, you have a lot of data. This is always the same situation when we start about this. And then we have the topic about what to do with the data. I have just written some of these words you know better than me. And for the sensor network, we have the embedded AI topics, which are very interesting for us if you really do it on the sensor already and then decide what to send. And on the other side, there is also a very interesting field for us. This is this whole topic of virtual sensing. This means we don't have the sensor everywhere. We just have some sensors, and the others we just simulate mathematically. And I think this is a huge topic in the future to come. Embedded AI, this is something I do not want to go into deep detail. We have always a challenge about the big data, and we have these compression models and the compression techniques. We use them, and we try to adapt it to the different problems we have. If we think about the teacher's modeling, the knowledge transfer, and the student's model, you know all these wordings. But I think for us it's really important that we have the student's model on a very small device. The chip where the learning is on and that we want to use should be very miniaturized. And it should be integratable in our systems. And I think this is a crucial part. And therefore, when you all work on the efficiency of the models, on the learning, this is really making a difference when we come again back to the industry. Sometimes I have the challenges, the basic research is very far away from the industry. We often face this problem, and especially I at least have the feeling for data science it is the case. But the industry is changing. We see in the moment how far they are going to really make virtual sensing possible, to really go in the direction of AI and really including it. For the industry, for manufacturing, we will for years face the problem that we don't have a 100% decision. This is a huge topic for industry because if something goes wrong, they don't like to. But there are many parts in the fab when we think about predictive maintenance, for example, for reducing energy consumption, there this model would make the difference. And we really experience from our project partner, they want to go in these topics. And therefore, I think this whole data science topic will be really a huge topic also when we think about next generation manufacturing technologies. This is a topic we started some years ago. This was in the direction, if you think about the fridge, it was a project together with Liebherr. You think of the fridge, you want to know what is inside, you want to know how much is inside of the stuff you have, and it would be good to know what you should go shopping to prepare the dinner in the evening. And therefore you need to have a look inside to know what is inside, to know how full your milk still is and all this. And this was really, there is no chance whatsoever to do it with traditional models because we know how many different packages we have. But a model that is self-learning, it will get better and better. And I think our model works good for ice cream because this was the training part our people like to do. And they really could prove it's going in the right direction, but really showing this in this way, it will take some more years. But the first steps are done. And really the possibility to make a clear picture of the things inside and to have also installed on the shelf some sensors that you find out how much is inside. This is really these possibilities we have. And the next step is that the whole supermarket is in a small AI chip and everything is known. This is another topic I want just to tell you a little bit about. There the vision was PV power plants have the problem that sometimes they face problems. Yield is decreasing and stuff like this. And we found out with statistical abnormality detection, this is a very good way to find out what is the failure of the PV power plant. And you have quite a huge number of failures you can detect very easily if you just measure regularly the points. The difficulty there was more the direction of finding out what data should be skipped, because not all data are perfect. And best is working if you combine traditional models with always looking at the data on daily basis, on monthly, on yearly basis, but then combining also with traditional measurement methods. In this case, it was thermography measurements. Virtual sensing is really, for example, here a project where we try to, if you look at the picture above, it's really too much sensor lines, and if some of them we put to virtual sensing, it would be really a huge advantage. This was a topic where we have in the room many sensors, and the rest is just simulated. And I think this is really the future, when we just put like postcards on the wall on some places, and then we have all the data for the building available. So this is another topic where it makes really the difference. If we think about brain measurements, if we have really the possibility to measure outside and not inside, this is really changing a lot. Funny in this case was that the first sensor that was really brain implemented are now, we developed them 5-6 years ago. They are now in a clinical study in Switzerland. And our people are thinking about the next step already. So really, this is really going in the right direction and really changing, and this is only possible because of data science. Coming to the conclusion, modern electronic-based systems produce large data. Our sensors, we have a lot of possibility to measure, to send, and all this. So we need to do something with the data, and there data science is really a crucial part. I believe that the combination between data science and hardware is changing our world. And with the possibility to measure the environment, to measure the manufacturing, we get, and the combination to data science, we get really the option to change our world, to make it a little bit better without losing convenience, security for our daily life and the life in industry. Thank you very much.
Thank you a lot, Christina, for this very, very interesting talk. So a basic information for all of you. So this year it's a bit different. We won't have a question part now, but we will have a slot at the end of the session. So you will have 15 to 20 minutes to ask questions to all of the speakers. So just try to remember what you want to ask. But still, I would like to end it with a very, very small question, if that's fine, that you're not just basically leaving. So would you say, what's your opinion? Would you say that the fast evolving field of data science was a very big game changer for optimizing all of these huge sensor networks?
Yes, I think this topic was really the game changer, because as I have made the example with the brain sensor, it was completely clear that the sensor need to be installed in the brain, because there was no chance to evaluate it in another way. And also 5-6 years or 7 years ago, when they start to think about this project, the people thought already about the option for measuring outside, but they didn't exist. And only data science makes such things possible. And the same is if we talk about, I had one of the LEM research machines on my slides. We did a big project there. And you have one thing in this chemical, very nasty surrounding, you need a sensor that survives. But this is only one step. You don't like to wire, because I've shown you the picture with all this wiring. You don't like to wire. So one thing was really this situation that you have devices without wiring, you can power the devices. And then with measuring all this data, there are a huge amount of data. And only the change in the data structure can show you when to maintain, when to do something, when it is necessary to order a spare part. And why is the process not optimized? And only this slight change and this early information of the changes make it possible to improve predictive maintenance and also the processes. And I think this is crucial, and this is only possible with data science. And I think this possibility will increase in the future.
Hopefully.
Yeah, I'm convinced of it. The only danger is if we have, as I said in the beginning, groups that I say, I'm making AI, and I do not care what are my data on the other side. We really need to think, what is mathematically, statistically, or also it's not sexy anymore, possible to change something. And with really this thinking about, the mathematical thinking about what is the right method to be done, I think there can be really a huge improvement. And when the algorithms you are all developing get quicker, get more secure, I think this will change also the hardware-driven world.
Okay, thank you a lot. Thanks again, Christina.